Okay, I hope my screen is visible. Unfortunately, that recording, I'm going to need to try to see if I can restore, but well, heartbreaking. You can see and you can hear me, right? Awesome. Okay, where were we? We're supposed to do that grade 11 question. Let's see. Yeah, this is grade 11. Euclidean will start from grade 11 and then move on like that. Okay, we earlier on analyzed to say that AB will be equal to what? 3 over 2x, right? And what? Am I recording though? And that AC will also be what? Is that fine? Okay. Calculate the size of O1. Rounded off to the nearest what? Degree. O1. Oh. I want you to see the beauty of this and the connection. Now, AO is a radius. I'm looking for this angle. Normally in Euclidean, we don't really calculate that much. We just use reasons to say, but now they want an angle. But do you notice AO is x, which is a radius. What about OB? It's also a radius. So what do I have? I have 3 sides. Trigonometry, cosine rule. I have trigonometry because I now have a triangle where I have 3 sides. I'm going to give you the formula, but I'm going to ask you to please do the calculation for me. So you cannot say, oh, you are done with one topic, you're now doing another topic. No, it's maths. Check here, I have x, I have x, I have 3 over 2 what? X. And I'm looking for angle O. Do you notice I have 3 sides? I have 3 sides. And when I have 3 sides, what do I use? Cosine rule. Do you remember cosine rule? This one, okay, hold on. This one, we can use letter A, right? Letter small b and letter O. Since I am looking for angle O, I can say O squared equals to what? A squared plus B squared minus 2AB cosine rule. Now, what is O squared? 3 over 2x squared. I wasn't expecting this at all. I wasn't ready for this. X squared plus x squared minus 2x multiplied by x cos what? O1. Can we expand? I'm not ready for tricks. What do we have? 9 over 4 x squared. What would this be? 2x squared minus 2x squared cos O1. Guys, please take note. All of these are together. Don't say 2x squared minus 2x squared is 0. Let's bring all of that to the left-hand side. What do you have? 2x squared cos O1 equals to what? 2x squared minus 9 over 4. This has nothing to do with Euclidean. What do we do? What is 2? These are like terms, right? 2 minus 9 over 4. That is what? 4, 8, negative 1 over 4. All right. So 2x squared, we are revising trigs. What do we say? Negative 1 over 4 what? X squared. What do we do? Divide both sides by 2x squared. What would that be? The x squared will cancel each other. I hope we see that, right? Cos O1 therefore will be what? 1 over 4 divided by 2 will be 1 over 8. negative 1 over 8. What do we then do? We need to find our reference angle, right? But check for me, is it negative though? Will it be negative? Yeah.
That's 8 over 4. Yeah, it's
okay. So if it's negative, then we need a reference angle, right? Remember, this angle cannot be negative though. This one must be positive. So what's your reference angle? Arc cos of what?
97,1.
90?
7,1.
You sure? 1/8. But now this cannot be our, let's see, can this be our answer?
82,81.
Okay, Shamir. Yes?
I got a second answer.
What's your answer?
82,1. 82,82.
82,82.
So do you put in the negative?
Okay, ideally, don't put, okay, let's go back to tricks. Ideally, don't put the negative. Alright? If you don't put the negative, this is what you have.
Yes, if you don't put the negative, this is what you have.
Don't put the negative. What are we looking at? Let's go back to our trigonometry. Now, that's why I said ref what? Angle. Alright. Now, but this one, we see this one should be in quadrant number what? 2 or quadrant number what? 3. Are you with me there? Let's maintain the same system. What's our reduction? 180 minus the reference what? Angle. Make sense? Now I'm looking for theta O1. Angle O1 would be what? 180 minus 82,82. And what would that give you? That might give you a 97 now.
Yeah, 97,1.
Let's maintain the same system of solving. 97, what? Are we okay, everybody? This is complete trigonometry. There's nothing. This has nothing to do with trigs. Euclidean. Oh, check. If O1 equals to 97, question 2, and x equals to 10, calculate the length of what? AC. Correct to 2 decimal what? Places. This is I wasn't ready for this. I was ready to look at reasons and angles. But are we okay? Let me check. Yes, Mohammed, are you okay? Guys, let me know. Are we okay with the first question?
Sir,
Yep.
did you have to go?
Oh, they said rounded off to the nearest degree. Sorry?
Do you have to go finding a reference angle?
Yes, I've just
You
preferred.
say arc cos was negative.
I prefer to just work with. You know why? If that asks us to find O2, I just prefer to work one system. Rounded off to the nearest what? Degree is 97 what? Degrees. Okay. So this is trigonometry, has nothing to do with Euclidean, but it's maths. And I'm actually glad that we came here, because somebody would say, okay, I have now crossed to Euclidean, and forget everything trigs and be looking for angle at the center equals to, which would not make sense, and we get stuck. So please, let's be open-minded. If O1 equals to 97 degrees and x equals to 10, calculate the length of what? AC. Please take note, this is Free State 2020. Should you want to download and make a reference? Yes, Limu?
Sir, when they say 15 calculate the size of O, aren't we gonna end there at when we found arc cos 1 over 8?
No, that's a reference angle. Do you know?
So when we say solve for,
Yes?
so when we say solve for x, 3. Do you have to find the general solution?
Yes, because 82,82 is not the correct angle. It's the angle in the first quadrant. But our negative 1 over 8 tells us we are in the second quadrant, or what? The third. So the second quadrant tells us our angle must be greater than what? 90 degrees. That's why we cannot end at 82,82. So I use that. I don't like throwing the negative in because I want to maintain the same. If you notice now, we've actually revised general solution so that we maintain the same system all the time. When we get to analytical geometry, we're going to do the same thing. We're going to always remove the negative so that the concept of general solution remains with us completely. All right, we're good. 9.2. If O1 is 97 and X is 10, calculate the length of what? AC. O1 is 97. What are we looking for? Length of AC. Let's see. Let's analyze. I'm going to help you with this because we're not here today. This is 7 degrees. Automatically, I know what my A1 would be and my B1, but that's not important. Let's see what we need to do. We are looking for what? AC. What do we know? All right, check. Wait. Are you aware that this angle will be equal to that angle?
Yes.
What will be your reason? Now, angles opposite equal side. It's an isosceles triangle. How do I know it's an isosceles? Those two sides are equal. Now we can find angle C by using Euclidean. Angle at the center is 2 times angle at the circumference. Can you please get me angle C? What's your angle C going to be? I have 2 answers for you. Is my answer 194 or my answer 47,5? 48. The one on the circumference is always the smaller one. Please take note. The one at the center is bigger. The one at the circumference is smaller. So what is this going to be? 48, what? Do we all, everybody agree with me? And if that's the case, this one is also what? Then I can use my sine rule. This over that equals to this. Does that make sense? Please talk to me. Let's see if it makes sense to everyone. We're not really, I wasn't really ready for this Euclidean trigonometry, but it's maths. Maths is maths anyway. So we have a triangle. I want to see the shape of that triangle. Or let me just copy and paste this one. Okay guys, I hope you get the reasoning. I want us to go to real, just mainly Euclidean today, but okay, so we start by saying angle C equals to what? 48,5 degrees. What's your reason? Angle at center is equal to what? 2 times angle at circumference, right? I hope everybody's okay. Now we have angle A is also what? 48,5 degrees. What's your reason? Angles opposites equal side. That's an isosceles triangle. We can therefore say that BC over sine A will be equal to what? AB over sine C. I hope that makes sense. Sine rule. But sine A and sine C are the same, right?
Yeah.
You know what it means? It simply means BC should also be equal to what? But it's not going to make sense. Then it will be giving me what? Equilateral triangle, which is not giving me 60 degrees. Maybe there's a problem with this. We'll check again.
No, but so we want AC.
We want what?
AC.
Oh, we want AC. What did I write?
PC.
Sorry, hold on. We want what?
AC.
Oh, sorry. AC. Oh, yeah. I was. So it was AC over sine B. Sine rule. B we can get. Sum of angles in the triangle. Alright? AC over sine B equals to what? AB over, yeah, correct now. So what is AC? Now what is sine B?
B is
80?
83.
You sure?
Yes.
Alright, 83 equals to what is AB?
AB is
We are told x is 10. Right? So 30 divided by 2, 15. Over sine what? 48,5. Please quickly check for the answer for AC for me. We're going to check now and check our first 9 marks. Use your calculator, please, quickly. I hope it makes sense. It's just trigonometry here, sine rule. This is a beautiful question. This was to throw learners off.
19,88.
Shamil, please finish. We've been through this. We've been through this, and I don't want to say that again. And right. Cross multiply and right and divide. What are we getting? 19,88 to 2 decimal places. Somebody's giving me 19. Fatima, you're giving me 19,9. 19,88. So far we only used one Euclidean what? That's boring, man. I wasn't ready for that. Are we okay, everybody? Wasn't ready for that, but it's a good lesson to show us the merge. Beautiful. Okay, let's go. Can I move on? I want to move on to real things for what we are supposed to be looking at. Okay, I think the next one, the next one definitely is all Euclidean. Yay! Finally. Okay, guys, come. We are doing this together. Let's read first. I know you are already saying angle Q1. No, read. In the diagram, TP is what? I'm going to quickly write. Please, it's the skills now. I'm writing my tangent there. Is that okay? Already I'm thinking of tan rad. I'm thinking of tan chord. Those are the two. Already I'm done with one angle. Just by focusing on that tangent, I'm already done. Because, check. Okay, let's read through. QS is a diameter. Already I'm done again.
Yes.
You see, reading is important. QS, so 2 important words. Tangent. Now I see what? What comes to your mind when you say diameter?
90 degrees.
A 90 angle, what? Alright, so if I look at my diameter, which one is my diameter? That. Oh, so which one? Please, everyone, which angle is 90 degrees here?
P.
The P, there are 5 angles there. You've got to trace the correct one. And that's the one that is 90. How do we call this angle? QPS. angle QPS. Don't just say angle P, because angle P in itself is not 90 degrees. Okay. Now, TPS is 32. Can you see how they named it? Now, my first question is to Q1. I gave you 3 points for grade 11. Trace the source of the angle. Guys, look at how I'm going to use it. I'm using point 1 now. The examiner wants me to find what? Q1. If you learn this, you're going to save a lot of time. I'm looking for Q1. Let's trace it. Source. That. Do you notice the source is PS? Oh, what is PS? PS is a chord. You see, once I cover that, we are done. Oh, a chord and a tangent. Put those two words together. Tan chord. 32. 32. Q1 is 32. 2 marks. And what's your reason? Talk to me. Are we okay? 1 mark there, 1 mark there. Everybody okay? Trace the source. Guys, it's about speed. Please, it's about what? Speed. Okay, so Q1 is 32 degrees. I don't want you to waste time. Wait, there's a center there. Do you notice that's a radius? That is, if you go back to the note I gave you, I said once you see 2 radii, or when you see radii, angle at the center is twice angle at the circumference. And also think about what? Angles opposite equal what? Sides. Can I take you back? I don't want you to say, okay, we only do that for science. Check here. Everybody, look at it. Look at it. Radius. Angle at the center is 2 times angle at circumference. Look at the bottom. Angles opposite what? Equal. Because I have radius. It gives me an isosceles what? Triangle. Already, I think I am done with the next question. Do you think we are done with the next question, everybody? We are looking for P4. Check. P4 is also what? 32 degrees. P4. Guys, the next grade 11 one, I'm going to keep quiet. You're going to answer the question, so please take note. Angles what? Opposite equal side. 1 mark. Please don't write the word isosceles. You get a 0. M1. Let's trace. What do you notice? I'm going to use highlights. M1. Oh, where's M1? It's at the what? Angle at the center is 2 times angle at the, because they are both coming from PS. I don't know if you see that. Again, let me use a red one. Trace it back. It's at the center. Where is it coming from? PS. Does PS go anywhere on the circumference? Yes.
So there's 3 ways.
3 ways. Okay. Let's see. What's your answer for M1?
64.
64. The center one is always the bigger one. 1 second there. Now, lady.
Is it okay if you use if you look for M2 because of the angles in a triangle of PMQ, and then use angles on a straight line to look for M1?
Yes. You can actually also, yes, I see what you're saying. I didn't even see that. You look for this and then say angle on a straight line. Or you can say exterior angle is equal to sum of opposite what? Interior. Exterior is the one outside. Okay, so beautiful ways. 3 ways of getting that particular one. So M1 equals to what? 64 degrees. What did we say? Angle at center is equal to 2 times angle at circumference. What was the other reason we said? Exterior angle of what? Of triangle. And please, once you get an angle, write it there. Angle R. Oh, I'm done.
Yeah.
I am done. Because check, trace the source. Trace the source, angle R, right? Where is it coming from? Does PQ go anywhere else? Yes. PQ go to S. What's that? Angles in the same what? Segment. The question is, can I get angle S? Yes. Oh, S is in a triangle. What type of triangle? A right. You see why it's important to write the things that you have? So what is S? 90 minus 32. But 4 marks. Let's show the 4 marks. First mark would be to tell me that that angle is what? 90 degrees. QPS equals to 90 degrees. What's your reason? What's your reason?
Even.
No.
Oh, yes.
Angle in a semicircle. Angle in a semicircle. That's 90 there. Then angle S. What is 90 minus 32? 58.
58, yes.
What's your reason? Sum of angles in a triangle. Then angle R therefore should be equal to what? 58 degrees. What's your reason? Angles in the same what? Segment. How do we mark this? 1, 2, 3, and 4. I'm always very jealous about these questions. They are easy questions that a learner must. This is your 10 minutes reading time. I've always been saying that. Don't look through the whole paper. Whether you like it or not, you're going to open every page. It's 3 hours. Why don't we use our 10 minutes for something qualitative? You can do this in 10 minutes. Yeah, this is the multiple choice that we have in maths. Okay, anyway, let's move. That one was very beautiful. I was hoping to do that, not that trigonometry thing that we came across. All right, let's go on. Oh, my proof. My proof. Complete the statement. If two triangles are equiangular, we did that today, then the corresponding sides are proportional. If you miss that, you miss 1 mark. That is what? Similarity. Take you back. I like my notes. Look at my similarity theorem. If two triangles are what? Equiangular, their corresponding sides are. So all the 1 mark is under the word what? Proportional. You get that 1 mark. You forget, you start having headache in the exam. You say, but I remember this word. But I remember this word. So more than proving, please let us get to know the wordings of the theorem as well. What's our answer? Okay, guys, I am doing this proof for you to remind you. This is proportionality theorem. Do you know the first thing I'll do? I'm going to, please watch what I'm going to do here. We did this last week. I am going to construct. Right? What am I constructing? Perpendicular what? Heights. It's a recall. Let's call this H1. Let's call this what? H2. What are this? Vertex of my triangle, if you remember. Also the vertex. KY. Join that one. So take note. That's what you're looking at. I'm going to start very fast. Construction. Please, you must write the construction there. Construct perpendicular what? Heights. Don't just say height. H1 and what? H2. What else did you do? Join what? KZ and... Everybody okay there? Good. 1 mark in place. I'm done. Out of how many? 6. I have 1 mark. What did I tell you about XK and KB? Do you remember what I said about this? I said this would form the base of your triangle. So if you look at XK, what's the triangle going to be? XKL. L is the vertex, it's on the other side. So, quickly, check. Area of triangle, use the letters they gave you. X, K, and where's the third side of the triangle? Point L, right? Over area of triangle, go to the base. What do you have? K, Y, you are using the same one, L. Don't worry, it's half base times what? Height. Half. What is your base? Copy from the question again. X what? K. Now what is your height? In this case, H2. Over half. What is your base? KY. Please learn the system because the next time you are going to prove this. It's a system and I'm trying to explain my steps. The half will cancel the half. The H2 will cancel the H2, Shamil. Next one you are proving because you're busy. XK over what? KY. I'm done with the left hand side. Do the same for the right hand side. What would I have? Area of, what is the base that I'm given? XL. What's the vertex? K. It's very simple. Look at, you are given what? XL, right? XL. So XL, jump to the other side in the middle. K, I'm done. Area of what? XLK over area of, what is the base you are given? Look at the denominator. Triangle what? LZ, repeat the letter. K, very simple. It must contain half. What's the base? XL, H1. Half, LZ. Do you notice what I have now? XL over. Now what do I need to do? Prove that the top are equal. Prove that the bottom are equal, and case is closed. Look at the top. Let me highlight for you to see. XLK, XKL. Do you notice it's the same triangle? XKL, XL. We're talking about the same triangle. So those triangles are what? Equal. What about the bottom? KYL, KY. Can you see that triangle? And what? And I look, just go straight. Look at what I'm going to write. Area, what's the bottom? Triangle KYL is the same as area of triangle what? LZK. What's your reason? Common base and what? Equal height. I explained why the heights are equal. Because they are bounded between two parallel lines. I am done. Therefore, the left hand side is equal to the right hand side. XK over what? KY equals to what? XL over what? 6 marks. Just follow the process. I want to see something, guys, quickly. Just hold on. I know you're writing. I want us to check something. It was a free state paper, right? One second. Open file location. Find it for me. What question was this? Question 10, right? Guys, please, I wanted to see what I did for you as compared to what the examiner will be marking with, so that you are rest assured. Can you see the construction? Exact same thing. Can you see? Join, da 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 da. How many marks do you get? 1 mark. Your left hand side, 1 mark. Your right hand side, 1 mark. All right. Your area of triangle XKL, the top. Is that fine? Now, area of your statement and your reason. You see, there's no mark here. If you notice, I even skipped it. Do you notice I didn't write it? I'll go back to the memo and show you what I wrote. I didn't even write that part. There's no mark there. But the next one, but the area of the denominators, they are equal. And what's your reason? Same base and height. Statement 1 mark, reason 1 mark. Then the area of the left hand side is equal to the area of the right hand side. Let's go back to my memo. So look at construction, 1 mark. Left hand side, 1 mark. Right hand side, 1 mark. Statement here, reason, 1 mark. One line that I skipped was to make a conclusion before this one, to say, therefore, area, you write what's on the left hand side on top there. Area of triangle what? XKL over area of triangle what? KYL. Now we go to the bottom. Area of triangle what? XLK. Because you have proven that the numerators are what? The same. And also the denominators are the same. What did I write? LZK. Now you get your 6th mark there. The last one has no mark because that's what they ask you to prove. Let's just write this one here. Area of triangle what? XKL is the same as area of triangle what? I hope you'll be able to get those 6 marks now, please. Straightforward. Are we okay with the proof and the steps? The next one, guys, which definitely we are going to come across, you will be doing that proof. And I'm not going to allow you to copy from your book. You must just be able to prove. Again, I didn't just prove, I gave you the steps so that you remember how to get your answer. Please look at the steps again. Construction. Whatever they give you is known as the base. And the vertex will be on the other side. Left hand side, right hand side. Prove that the areas of the tops are the same. Areas of the bottom the same. And voila, you're done. Simple. 6 marks. Guys, are we okay? Let's go to the real deal. All of this we are still playing here because this is just what? Copy and paste. Recall. Copy and paste. So how do you learn it? Write it over and over again. That's why I said the next time we see this question, I have done it, I have revised it, I'm not going to do it again. You will do it. To say, okay, was I really listening? Do I know the process? And if you can get it right now, we're good. Can I move? It's in your book. We wrote it last week, right? Yeah, it's in your book, so don't let... You just need to rewrite it. That's what matters. So many times. Okay. All right, beautiful. We are now in the real deal. This is now the real deal. Look at this triangle. Beautiful. Yeah, now we want to do real things, not those funny things that we're given. Okay, my good learners, I hope you can see, you'll be able to see the questions. I'm going to make them small. Okay, they are all 3 marks. We don't need the marks. 3, 3, 3, that's 12 marks. Let's see something here beautiful. How will I start approaching my grade 12 Euclidean? I start by reading and making my small notes. In the figure, D is a point on the side BC of triangle ABC. Let's go trace. I like to first find where those points are. D is a point, okay, on the side of what? BC. All right. What is BD? 6 centimeters. So I'm going to come here and write the value. What is DC? 9 centimeters. Be careful how you label. T and E are points on AC and DC respectively, such that TE is parallel. Now, please watch this next point. AT ratio TC is 2:1. AT to TC. Please, I want you to listen to this part. If you write it like that, you are wrong. Because I want you to check the difference between the labels. That's a ratio. This is the real length. When I say 9 centimeters, that's the real length. But when I say 2:1, it doesn't mean that 80 is 2. No, it's a ratio. For all I care, check. 80 could have been 4 centimeters. And TC would be what? 2 centimeters. If I divide, what would I get? 2/1. Can you see that the 2 and the 1, the ratio is not the length. So what do we do when we come to Euclidean? You are going to introduce letters. Every time I see ratio, I'm going to, you can use any letter, 2x and 1x. You can use k, you can use whatever. But make sure the ratios, the letters on one side are the same. Please, I'm going to show you quite a number of questions. Take note. Ratios are not lengths. Introduce what? Variables. The ratio is not the length. Introduce what? Variables. Did we get that, everybody? Please put that note down for me. Go back to where I said you should leave some points, some lines. Ratios are not lengths. Introduce what? Variables. Let's make that point 10. Ratios are not what? Lengths. Introduce variables. There's something I'm going to teach you as well, which I'm just remembering now. Introduce what? Variables. I'll teach you that probably next week. But just go with me so far. Everybody okay? We okay so far? All right. Now, show that what? D is the midpoint of... How can you interpret that for me? In terms of the length. It means what? BD must be equal to what? DE. It means that, can I try to get this one as what? If I can get that at 6 centimeters, then I'm done. Are you with me? What catches your eye in this triangle? There's something that catches your eye. Parallel lines. 0.7, I think. Or 0.8. Please check for me. There's something that says use proportionality when you see triangles with parallel lines. Point number?
Yeah, 6.
Oh, 6. What does it say? When you see a triangle with what? Parallel lines, what do we use? Let me highlight that for you, everybody. Please check. So I have a triangle. Can you see my parallel line? What's this? And I have this triangle. Oh. Can I draw that out for you? Let me draw that out for you beautifully. All right, so you can see parallel. What is this? A, T, C, D, E. I know this whole thing as what? 9 centimeters, but I don't know DE, right? But what do I know here? 2x. Can we try to write the sides? I am looking for DE, right? But I know DC. Please watch my writing. I don't know DE, but I know DC. But I have parallel lines. So I'll say DE. Please, I want you to listen to this part. DE over DC. My board is misbehaving. I'll go back there to show you my labeling. Watch again. Please look at the lines. DE, the small part, over DC. And I can only do this because there are parallel what? Lines. What should it be on the other side? AT. Some of you are lost. Guys, come with me. Come with me. This is what we have. This is where we are. Don't worry, I know it's the first example. Okay, perfect diagram. D, E, C, A, T. What does it say? 2x, 1x, and this whole thing is what? 9 centimeters. So I'm saying DE over what? DC. Can you see it is the top over the whole length? I will go again. It will be what? AT over what? AC. AT, and you must write what? What's your reason? Proportionality what? Theorem. Which lines are parallel? AD parallel to what? TE. Let me know if that makes sense, everybody. The movement first, before we start solving. The movement is important. Do I know DE? Nope. Do I know DC?
Yes.
What is DC?
9 centimeters.
9 centimeters. Over what? What is 80? Over what? You notice the x's would cancel. Let me leave centimeters here for you to see. Nothing is cancelling the centimeters, right? Let's cross multiply. No, sorry, over 3. It should be over 3. Over 3x. Do you know how we got the 3?
Yes.
Do you know how we got the 3? Somebody raise their hand. Okay, can we cross multiply now? What do we have? 3DC equals to what? 18. So what is DC?
6.
Was that not what we wanted to prove? Now we have proven that what? D is the midpoint of BE, because we are saying if that's the case, then DE should be equal to what? 6. Now we have our DE as 6. Let me take your questions from here. Yes? Linda Kutle? Look at the length of AC. Look at AC. Can you see AC there, Nana? So what do you think AC would be?
3x.
Yeah. It's the whole length. 3x. Guys, are we okay? Let me see. Thumbs up, thumbs down. Did this make sense? All right. So we can conclude, therefore, B is the midpoint, right? B is the midpoint of AE. Was it AE? No, I'm lying. D is the midpoint of BE. D is the midpoint. So first thing is interpretation. What am I looking for? Next question. What are we looking for? If F what? D is 2. Calculate the length of TE. Interesting. Interesting. I'm going to cut out that triangle for you. I'm going to cut out that triangle. We have a triangle that looks like this. We have a triangle that looks like this. We have this. And we have this. This is what? B. No, I'm wrong. Yeah. Let's go back to the lettering. It's B, D, E, right? And then F what? FT. B, D, E, and then what? F, T. These two lines, don't forget, they are still what? Parallel. Look at the diagram again. Can you see that those two lines are parallel? What do you notice about D? It's the midpoint. D is the midpoint. How do I know? Well, we have proven it, right? And these two lines are parallel. And we're told that FD is what? I can simply come and say TE equals to what? What's the reason? And I'm done. I don't even have to do any other thing. 3 marks. How did we prove that that is 4? How did we prove? Let's prove it using ratios. Let's prove it using what? Ratios. Remember what I told you. Do you know, please, I wanted to say this. Do you notice that FD is the base of a triangle? And TE is the base of another what? Go and read point number 5. No, yeah, number 5. When the base of a triangle is required, what do? Prove what? Similarity. And after similarity, what do? Write your ratios. Can we use that method? And let's see, quickly, everybody. How am I going to prove it? To prove similarity, what do I need to do? Only prove 2 angles. Yes? Kwesi?
So how did you get FB to become 2?
It's given. (10.3.2). Can you see the question?
Yes, sir. Thank you, sir.
If FD is 2, calculate the length of TE. Okay. Come, guys, let's work. If I want to go that it's long, all right, but let's work with we're practicing. I will consider triangle BFD, the top triangle, and the big triangle BET. Why? This angle is common to both of them, right? I'll use colors. Do you notice this angle would actually be equal to that angle? What's your reason? Corresponding angles. Okay. So if I want to do a full write-up, angle B is common. Angle D is equal to angle what? E. What's your reason? Corresponding what? Angles. Which lines are parallel? FD. You must always write that. What will I say about angle F and T?
Angle F is equal to angle T.
What's my reason?
Corresponding angles.
Third angle. You can also use corresponding, but third angle. Therefore, triangle what? Order. B, D, F is similar, because I used angles to triangle what? B, E, T. If that's the case, can I write my ratios immediately? Oh, what's your reason here? Angle, angle, angle. What do I have? BD over BE equals to what? DF over what? ET which is equal to
BF
BF
over BT.
over BT. What are we looking for? We are looking for what? TE, the middle one. Are we fine? Okay, which ones do I have? Let's go. Do I have BD?
Yes.
Yes. Do I have BE?
Yes.
Yes. Oh, so all I need to do is to use this combination. Can you see I have 3? No, do I have DF? Yes. And I'm looking for what? And it's a matter of cross multiplying and solving the case now. So what do I have? I'll come here and say BD over what? I don't have to use the 3. Equals to what? DF over what? ET. Reason? Similar triangles. Can you see it's long? But it's important. What are BD? 6. What is BE? 12. What is DF? 2. What is that? If you cross multiply? 4. Are you sure? 24 divided by 6, right? Good. Or you can use ratios of grade 8. 2 times 3 is 6. Am I right?
That's 1 over 2. We can just bring it over. It's 2 times 2 is 4.
Yeah. So ET equals to what? 4. This is the full write-up. But a learner who comes here and say D, let me just say, is the midpoint. And I want us to check, I want to check the memo of BE given. Therefore TE, it's just double. Each side is half of the long side. This is half of this. This is half of that. This is half of that. That's the midpoint theorem. So a learner who just writes this would get full marks. A learner who writes this would get 3 marks. They won't give you extra. But it's important because there are times we need to go through the second method just to show you the write-up. Are we okay? Let me take your questions. Today I'm not going to do something complex. I'm doing common things. This one is very common. Yes? Karabo? Karabo, you have your hand raised. Kwesi, is this an old hand raised up?
No, it's an old hand.
Okay, Karabo, your hand raised. All right, guys, thumbs up, thumbs down. Let's see. I'm waiting for Karabo. Thumbs up, thumbs down. Is it making sense? I know we are getting our first exposure, but we're going to get there. Sir, is it a must for us to write all this text? Yes, sir. It's a must. Let's see. Let me check the memo. Karabo says, is it a must? If I'm using this second method, I need to write all of that because you need to prove the angles first. Let's see. What's this? 10.3.2. All right, 10.3.1, we're fine, right? ED over, let me make it bigger because I want us to see. This is like chemistry. You don't just write anything. ED over that equals to that, 2 over 3 DE, that. All right. Okay, BF equals to TF, the converse of midpoint theorem. FD equals to half TE, and T equals to 4. Okay, they didn't do the other method. They just went straight and used what? Midpoint theorem. But that other method, you need to know. Okay, guys, quickly, what brought me to this paper? Because I just remember this is one of the papers that have this, and I want to show you this. Once I show you this, we're going to go back and look at another set of questions, something common, before we start doing things that are not common. Area of triangle what? 8. Guys, can you see that the two questions are kind of similar. This is what brought me to this paper. Area of what? ADC, area of ABD. Please go to your point 9. Keep your point 9 in front of you. Let's look at triangle ADC together. And you're going to tell me whether we are using point A. I gave you 3 points, right? You're going to tell me whether we're using A or B. ADC. A, D, C. Can you see that triangle there? And what? Which other triangle? ABD. A, B, D. Oh, I see. Do you notice the triangles are side by side? That's what we have. All right. Beautiful. What do you think we should do? Do they have the same angles? Let's go back. That's one triangle. Are the angles this? Are there any similar angles there? No. Do we agree that we cannot use the one that says what? Yeah. We cannot use the one that says angles, right? My good learners, I want you to watch something that I'm going to show you here. Everybody. I should actually have drawn this diagram for you when I was explaining that thing. My board is misbehaving. What's the story, man? Yes. Come on, board. What's the story? One second. This board is just beginning to do what it wants to do. Yes, somebody was raising their hand.
Oh, it's okay, sir. Sorry. Oh, good.
Okay. All right, guys, look at what we have, and I want to explain. So this is what brought me to this particular paper. I'm not sure which side. Okay, A, B, and 9. It's fine. Everybody, please watch this. Whenever I see this, I am going to use point 9. What was 9A?
Use A is equal to R, B, H.
9A. Use point what? My triangles are side by side. ADC and ABD. Do you know why? Please watch this. What am I looking for? Area of triangle. Let's go back to the question. Area of triangle what? ADC over what? ABD. ADC over area of Now, do you notice, please watch this. Do you notice that when I was highlighting, something peculiar came up? That's the base. That's the base. Are you with me? What's this triangle? Base and vertex. Base. Notice the base is on the same line. And it means the height is the same. So I don't even need to bother about the value of the height. So I am just going to come here and say, half, what's my base? AD multiplied by the height. I don't know what the height is, I don't care. Half what? AB multiplied by the height. No, wait. Half base, I'm using the wrong letters for the base. BC as my base and BD as my base. Because we're saying half base, that is the vertex there. And this is the base. So my base is on the same line and they have the same vertex. What happens to my height? It's the same. I don't know if that's why I'm writing HH there. Do we have BC? Wait, no, ADC. Sorry, why do I make a mistake here? Because we're looking at this triangle, right? So DC is the base. Do we agree? And then on the left side, do we have DC? What was DC? 9. What was BD? 6. What's my answer? Stop lying. 3/2. So I'm using, so this is how to use point 9a. The triangles are side by side. They have the same base and the same what? Vertex. It means they have the same height. I just use half base. The reason I'm using half base times height is so that their heights can cancel and their halves can cancel. I'm left with the base and the base. Please let me know if this makes sense. Does this make sense? This was what brought me to this question. I just wanted to show you this one, then we go back now and look at some other questions. Okay. What's the next one? I know you want to write, but just hold on. I want you to see the difference between the two. TEC and what? ABC. Please watch. Watch this. TEC. I'm looking at this, right? And what? AB. What do you notice? Do you notice that this angle is common? Don't worry about the size of the angle. It's going to be sine C, cancel out. The half will cancel out as well. These are the tips that makes Euclid. I don't know if it makes sense. So it's more of observation. What do I have? Let's go again. TEC. That's the small triangle there. And what? A, B. Oh, angle C is common to both of them. So which one am I using? Is it 9A or 9B? 9B. Which is what? Half AB sine C. Trigonometry, sine area rule. Let me know if my explanation makes sense. Let me know if my explanation makes sense, everybody. Quickly. I want to hear from you. Let's take your questions, if there is any question. It is, what is this? A, B, C, and what is this? T. Was this line like this? No.
Yeah.
No. Just like this. Doesn't matter that much. So which angle is common? Common what? Angle. What are we looking for again? Area of triangle what? TEC over area of triangle. We have already said, since angle C is common, we are going to use half AB. The question is, do you know how to use this from trigonometry? This is side, and this is the other side, and that's the angle in between. So for TEC, it is going to be half. I'm looking at this angle, right? So you look at this side. What is this side? TC and what? EC sine angle. Please take note. It is the side, and the angle between them. Again, I want to repeat. Which is the angle? Angle C, right? It's side, the side, and the angle between. That's why I have TC, EC, sine C, A, B, D.
Oh, because C is included.
C C is the included. So what do you think? Help me with this one. Let's work together. Triangle ABC again. A, B, C. I'm using angle C, right? What will it be? AC, BC, sine C. AB. Please listen. This is trigonometry. In case you were struggling with it, this is how to do it. It is the side, the angle between them, and the side again. What do you notice? The half would cancel. Do we know TC?
No.
Ah, stop lying. It was 1x. Huh? No, TE is 4. TC is 1x. I think so.
Yeah.
What is EC? 3. What is AB? Why am I saying AB? Half. No, it's supposed to be AC, not B. Yeah, somebody's raising a hand there. It is half AC, BC. Yeah. What is my AC? 3x. What is my BC? It's not 6. Go back to the diagram, everybody. I'll take your question now. Again, remember, we said this, and the angle between them, right? And for the small one, it was that, and the angle between. So we said what? 1x. This is where we got the 3 from. I'm sure somebody was asking where we got the 3. Do you understand where the 3 came from? It's 9 centimeters. Kwesi, where are you lost?
When you included signs that
It's trig. Area rule. Go back to point 9. Go back to point 9. It's given in your notes. Look at point 9. Were you checking point 9?
oh, okay, let's see.
Use area equals to half AB sine C. That is from area rule in trigonometry, if you remember. Half AB sine C. If the triangles have an equal, or no, please change this word. Change this word. This word is not right. If the triangles have a common angle, please change that word. It's a common, so that it can cancel out. A common English. A common angle. I know you guys don't speak English, so for me it bothers me. A common angle. Kwesi, are you there now?
Yes, sir. Thank you, sir.
An area rule, and I did mention use 9. That means you didn't read your notes when I said go back and read. Boy. All right. Okay. So what is my AC? 3x. What is my BC? 15. So what's my answer? Can you see that the x will cancel each other? So what's my answer? 1 over 15. 1 over 15. Let's just go down and see something quickly. Correct. You see, they use different letters, x, y, but the x's would cancel out, the y's would cancel out, and the earlier on we got what? 3 over 2. Okay. Please let's take note. Here, same base and equal what? Height. This one, examiners like it a lot. They test it quite a few times to see if you... So the reason I came to this paper is both were tested simultaneously, so that you can see. Do you know when to use which one? Please let me take your questions now, lady.
So can you explain how you got 15 again?
15. Let's go back to the diagram. So what length are we using? It's BC, right? Can you see your 15 already without me explaining? Six plus 9. 6 plus 9. All right, guys. Let's start again from a grade 11. Let's go through another cycle. I know this was quite hectic. Yes. There's a hand up. Yes, Brianna.
Sir, could you please do a question with the complex ratio?
I have to go find that. I'm not sure where that is. I'll have to find it. That one is very scarce. And when I was even writing the note, I said this one. But I need to go check. There's a document that I have. I'm going to look for it. It's that one. They don't really ask that because that one you have to sweat. But there's a document that I know I used some years ago. I'll have to go search and search and search. Years ago, I mean like 3-4 years ago, not so long. Don't say years ago as if I used it when I was in school. Asian times. Okay, let's find something here. Let's start from last year. Let's see what they were testing last year, right? 2024. Let's see what they were testing. Prelim. Okay, let's see. Free state. Ooh, what paper is this? Is it paper 2 or paper 1? This is paper 1. I don't know where my file. Oh, yeah, my file is here. Good. Eastern Cape. Let's see what they were testing. Guys, remember, for a few minutes, I'm going to keep quiet. There we go. This is theorem 1. 5 marks. Do you remember? I did it last week. Charles. I did it last week. This is where you use what? Congruency. Homework for you. Please make sure you learn. Before you sleep today, go back and learn this proof. Don't postpone it. Tomorrow's problem is coming. Don't add today's problem to tomorrow's one. Okay? I did that proof. All right. There we go. Come, get me 7 marks on this one. Maybe. Guys? 7 marks, yeah, quickly. This is grade 11. Come, please give me an attempt. Give me an attempt. Give me an attempt, everybody. Huh? You sure? Maybe. The teacher must have smoked something. All right, this is a grade 11 concept. In the diagram below, O is the center of the circle. Let's run through quickly. O is the midpoint of chord PR. QO, QS is the radius of the circle. PR is 8, and we are told those two lines are what? Equal. So what would this be? 4. Automatically, this is 90 degrees. What's your reason? Radius. 8.2.1. OQP equals to what? 90 degrees. What the reason? Line drawn from center bisects. Line drawn from what? Center. Line drawn from center that bisects or bisects a chord is perpendicular, and you're done. 8.2.2. I want to tell you the secret of this. Once you see this, guys, it's Pythagoras theorem. Now, look, here's the deal. This is just one thing that I need you to see. Once you see that, you're done. This is radius, right? You see OS, your eyes are going to deceive you. What is OS? It's also radius. And what is that? X plus 2. And we are done there. OP squared equals to what? OQ squared plus what? And what's the reason? Theorem of Pythagoras. Once you see a diagram like this, just know because of that 90 degrees. What is OP? X plus 2 squared. What is OQ? X squared. What is QP? All this give you? Plus 4x plus 4 equals to x squared. Alright, first the x squared cancels each other already. So what is 4x? 12. What is x? And we are done. 5 marks in the bag.
We're not done.
Oh, the length of?
PO.
Okay, so PO is what?
X plus 2.
X plus 2, which is what? 3 plus 2. And what's your answer? 5 units. Theorem 1 goes alongside with the theorem of Pythagoras. Yes, talk to me.
So how will you be able to find PO to be x plus 2?
It's a radius.
Oh, okay. Thank you.
I even wrote it here. Radius. And that's the same thing here. So OP is the same as what? OS.
No, it's not a doesn't look like it. You said it yourself before, so even that it gets iterations.
But your eyes, don't look at it with your eyes. It doesn't look the same. This is not even a circle, that's why. This is oval. I think. Alright, are we good? This is a common grade 11 question. It's an O, not a 0. Okay, next one. Remember, we revise grade 11 and then move to grade 12 like that. Yeah, this board is miles behind. Grade 11 again. But let's do it. Grade 11, because I want us to transit gradually. This is grade 11. I'll give you, this is 5 marks. I'll give you 5 minutes for you to think again. 30 seconds to read. Okay. Again, grade 11. Grade 11 work here. A, B, C, and D are on the circumference. Guys, this is not a cyclic chord. Why is it not a cyclic chord?
Because all the points are not on the
I only have 3 points. Okay. What am I looking for? Angle C. This is angle at center. But here is the challenging part. Here's the challenging part. You see this angle here is related to this entire angle. And what's this entire angle? This is 180. So this is what? An angle at the center is the one that is bigger, right? So what is C? 125. And we're done. No stories. 5 marks. Angle O2 is what? 180 degrees. Angles on a straight line. No.
Yeah.
No. Not O2.
Oh, yeah.
AOB.
You could say O1 is
No, O1 is inside.
10 and then angles are on the phone.
So AOB, which makes angle O2 to be what? 180 plus 70. And that gives us what? Now angle C is equal to 125 degrees. What's your reason?
Angles at center is 2 times angle at center.
Angle at center equals to what? 2 times angle. So please take note, when I was explaining, I think I did explain all the 3 triangles, all the 3 angles, or the 3 shapes. Let me show you again. There. The reflex one. Where I was saying if you keep moving the end. Alright. So take note again. It's there in the notes that we had. The note seems to be doing some good things, eh? Alright. Guys, I want to go to grade 12 work. Please, let's do this. Let's do this. There's some grade 12 work here. Beautiful. I'm going to take you through this. Please, I want you to walk with me on this. Walk with me on this. This is where learners start crying. My good learners, I'm going to take my time here. I want you to see something. B, C, D, M is a cyclic chord. Look, go and look for it. Have you found it? Chords M, D, and DC are produced to meet A. N is a point there, so that AC is parallel to what? Alright. Do we see parallel? Let's check something. Can you see that this line is parallel to this line, right? Is this in a triangle? Proportionality is coming in somewhere. Do you see that already? Parallel line and a triangle. Proportionality is coming in somewhere. AC is what? 36 units. AD is 48 units. Okay, we'll take all those measurements when we meet them. My beautiful learners, please. You see this thing here? It's 4 free marks. 4 what? Free marks. And I'm going to, this one is a very, very common concept. What is this? Ooh, can we go back to our point? I said, I knew it that I'm forgetting something. That's why I said, leave some places for me. I knew it. Let's make this 11. This is very important. Given or required to prove similarity. Please take note of this. This is very, very important. Required to prove similarity, just like the question we are going to do just now. Number 1, list the angles in order as given. Point number 2, find a reason for inequality, for equality. I'll explain. Find a reason for equality of two pairs of angles. I just missed this part. It was supposed to be part number 10. Two pairs of what? Angles. And for the third angle, what do you write? Third angle, right? Please, well, this is the Greek 12 one. Common. This is very common. So make sure you get what I'm going to do now. It's a common concept. It is a very, very common what? Concept. So I need you to stay focused. Don't get confused on this one. I know that this can be challenging, but please don't get confused on this one. I am told to prove. Can I go on now? Let me know. Can I go on? I am told to prove, and note the symbol, similarity, right? Not congruency. Please, my good learners, I want you to pay attention. This 4 marks. In fact, you see this 7 marks is very free. Prove triangle ABM. Oh, this one we are going to get so many times. It's similar. I'm going to go step by step. What did I say? List the angles. Guys, let's go to triangle ABM. It's A, B, and M. What angles do I have? A, B2, M3. Are you with me? That's what I mean by listing. So let's list it. What do I have? Angle A. Angle what? B2. Not B squared. Angle B2. And angle what? M3. Look at ADC for me. Come, let's go. A. We move to, where's D? D. And we move to what? C. So what do you have? Angle A. Angle D. And make sure you list it in order, the way you were given. ADC. Because the examiner asked me to prove this, and I have listed in order, it means this one is equal to this one. This one is equal to this one. All I need to do is to find the correct reason. And reason number 1 is already done. You see, I am listing in order. The angles are automatically what? Equal. All I need to do is to find the correct what? Reason. What can you tell me about the first one? Come on. I'm sitting on 1 mark already there. Out of 4. Have you done anything? No. B2 is equal to what? D. Not C. Yes, there's a hand there.
Isn't B2 equal to angle C?
B, wait, they gave us what? No. Guys, follow the order that you are given. Follow the order. Thank you. B2 is not equal. These lines are not parallel. I know you were looking at this line. These are not parallel. This and this are equal. Grade 11. X, that's a cyclic chord, right? Exterior angle of a cyclic chord is equal to what? Opposite interior angle. Oh, damn. What's the reason here? Exterior angle is equal to what? Opposite interior angle. I don't care what this one is. I don't even need to find why they are equal. I just need to find 2. Sometimes you may not find the second one and you find the third one, right? If I don't find the second one and I find the third one, I'll have to change the arrangement. Guys, you can't write third in position number 2. Something is wrong with you. Do you understand what I'm saying? When we say third, it means this is number 1, this is number 2, this is number 3. If sometimes you don't have this, and you got this one, you move this one up and drop this one down. And say what? Third, because third talks about position. Oh, I am done. I am now done. Check. What will I say? Triangle what? ABM is similar to triangle what? ADC. What's your reason? Angle, angle, angle. 1, 2, 3, and 4. Let me know if it makes sense. This is a common one. Common. Very common concept. Get it now, you get it forever. You'll just be chowing 4 marks, 3 marks. Minimum is 3 marks. You'll just be collecting. Every time you see it, you collect it. 3 marks, 4 marks, 3 marks. List the angles in order. Once I list them in order, I automatically know they are equal. What I'm doing is finding what? The appropriate reason. And how many angles do I need? 2. The third one, what do I say? Third angle. I move on and write your reason. But I did say something earlier on. Every time I prove similarity, what should I do? Please, whether you are done with the question, right? Just let's write the ratio. What's my ratio then? You want to help me? AB, let's put it down somewhere. Always AB over AD is equal to what? BM over what? DC AM over AC. Just keep it. Alright, we're done. Question number 2. Karabo, this is for you. Please watch the trick. I'm going to cheat here. Prove that CD squared equals to BM times what? AC. I'm going to cheat. There's a point that says given algebraic ratios. Check for me, number 7 or number 6. No, it should be number 7. Number 8. What does it say? Given algebraic ratio, find the triangles used and work what? Backwards. Now, this is what I'm going to do here. Please watch this. These are little skills. You use it, it's going to help. CD squared equals to BM times what? AC. Wait, for me to get CD squared, I must have multiplied CD by CD. Are you with me? Okay. Let's try to reproduce this on a fresh page. I must have multiplied what? CD by what? CD. So I want to work backwards. Or remember already I have my ratio there, right? Check. You see it already? Okay, I don't even know where we're going, but it always just works for me. CD squared is equal to what? BM. So if I cross multiply, it is CD, check, CD. Are you with me there? I'm working I want to work backwards now. Then BM times what? AC. Watch this. Are you okay there? Guys, are you okay with my first step? This is me thinking through. Okay, I'm thinking through. This is how we work. Go check the letters. You must have 3 letters. If I have 4 letters, then there's a problem. I have 4 letters here. There's a problem here. Okay, what about here? How many letters? 3. Because C is C. So I have A, C, D. Check. Is it a triangle? Yes, it is a triangle. Ah, sweet. I already have this triangle. Do you notice it's question 10.1? Now, let's go check CD and BM. I want us to check something. CD and what? BM. CD and BM. CD and BM. Go back to your ratio and let's check something quickly. I have AC and CD. It is triangle ACD, right? Okay. AC, watch me. AC. Do I have CD? AC over CD. Okay, wait, I want to check something. Wait, I want to check something quickly. Ta-na-na-na-na-na. Wait, I'm looking for CDBM, right? That's where my problem is. And I know that, I know that if I can get this, then I'm fine. AC multiplied by BM. Do I have AM here? Let me get a red pen. So this is me thinking. That's how we think in Euclidean. You don't just start writing nonsense. I want AC and C. Do I have AC here? Yes. We agree, right? I have AC. Do I have CD? Yes. We're good? What else do I need? BM? Are you with me? Are you seeing what I'm doing, right? I'm looking at my question. I have AC. I have DC. Can you see AC? I have DC. I have what? BM. The problem is what? CD. 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 And it's 3 marks. It's not supposed to be this difficult. CD. But the examiner told me CD squared equals to, let's go trace those lines. You've got to trace all the available things. We'll get you CD squared equals to what? BM and then what? AC. Yes? Did anybody see anything? But wait. Do you notice? Hold on, just 1 second. We have a triangle here, right? We have a triangle. We have a triangle. Do you agree with me? Yeah. We have a triangle, and this triangle has what? 2 parallel lines. Let me draw that out. I have a triangle, and it has 2 parallel what? Lines. Let's write out some ratios, and then we compare. These things are not always... if you see anything though, let me know. AC, what do I have? M, N, and what? D. Are you with me? Wait. What am I looking for again? No, this is not going to work. Oh no, wait. I have BM, right? I have AC. I have BM. I have AC. If I cross multiply, that gives me what? What I want, right? Then I have what? CD. AM is my problem. AM is my problem. Okay. But do I have AM? These 2 lines are parallel, right? AM. Yes. One.
It says AM is equal to CD given at the top.
AM is equal to what? CD. Missed that information. AM, thank you. AM is equal to, can you see that trying to work backwards? Hold on, let me go back to my working backwards now because I missed that information. So, working backwards, I said CD multiplied by CD, right? But they said CD and AM are what? Equal, right? Watch this. CD is equal to what? AM. I want to show you the working backwards method. CD is equal to what? So basically, look at what I have. AM over what? BM. Do we agree? AC over what? CD. You must have 3 letters. What letters do you have here? What letters do you have here? Check. That's a triangle and that's a triangle. And that's question 10.1. Does that make sense? I am using the question to identify the triangle. Oh, so if I can prove that these two are similar, then I'm done. Which was the first question that was done. Look at now my write-up. Don't worry, we'll get used to this. Look at now my write-up. From question 10.1, I now know that BM over CD is equal to what? AM over what? AC. What's your reason? I wrote this because triangles are what? Similar. But AM is the same as what? CD given. Therefore, BM over what? CD equals to what? CD over what? AC. Cross multiply. Can you see it's just the opposite now? AC multiplied by BM. Whenever I am given algebraic ratio, I work backwards to see if I can find the triangles. Did that make sense? I didn't see that information. Did that make sense, everybody? Yes?
Can you please explain?
Where are you lost, Charles? Talk to me. Tell me exact point what lost you.
From the beginning.
From the beginning. Did you get 10.1 correct, Lindo?
Yes, sir.
Okay. And I said, let me go through again. Lindo Kutle, and every other person. I said, whenever you're given a algebra ratio like this, right? Take note of what you are given and try to find the triangle used, because it gets messy. So, the examiner gave me what? CD squared equals to what? BM. Remember, in this we are always using ratios, we cross multiply. For me to have gotten CD squared, it would have come from what? CD multiplied by what? CD. So I'm going to turn this into a ratio. It's just a little scale. So that when I cross multiply, I get my CD squared. Then I have BM and what? AC. Just distribute it anywhere. You are trying to find 3 letters per side. What letters do I have on this side? If I have 3 letters, go and check. Is there a triangle labeled ACD? Yes. Can I tell, in some questions, they will not give you 10.1. They'll just go to 10.2 straight and tell you it's 7 marks. So right now, I am working as if I don't know 10.1.
Oh, I see.
You get what I'm saying? So I have ACD. Let's check. Is there a triangle called ACD? A, C. All you are looking for is a triangle. Oh, yes. I'm going to keep that. Then I have CDBM. That's where I had a problem, but I was helped there. See, because these are how many letters? 4. A triangle should have how many? 3. Oh, but I see the examiner says, but CD equals to what? AM. So let's go change it so that we have what? 3 letters. So instead of writing CD, what do I write? AM over what? Oh, now I have 3 letters. A, B, and M. Is that a triangle? I want to show you something. Let's say I don't know 10.1. I want to walk through. Is that a triangle? Yes. Do you see the triangle ABM now? Oh, it's a triangle. So I have 2 triangles. Guys, I am walking now as if I don't know this one. Like I said, examiners will give you that. So let me clean this. We don't know this. Now they will add those 2 marks together to make what? 7. All right. So 7 looks a bit too high. But how would I get it? Now I have 2 triangles. Once I see 2 triangles, prove what? Similarity. Now, in this case, I do not know the order of the angles. But my good learners, check. I have ABM and I also have what? ACD. Oh, you see, you need something to highlight this. I have ABM and ACD. A, B, that's one triangle there. And then quickly highlight the second one. Oh, what do you notice? Angle A is what? Common. So I'll start from there. There's a reason I want to show you this. So I have this ABM and what? Remember, I don't know the order. But I know that angle A, angle A. Okay. I said ABM. Let's check something. What is angle M equal to? I want to work in another way.
Angle C.
Do you notice that exterior? You see that, right? Okay. M is on the left-hand side. All I need to prove is how many? 2. The third one automatically becomes what? Equal. And what's the third one here? B2, right? This is M3. B2 should be equal to what? Angle what? D. Oh, so angle A is equal to angle A. What is that? Common. M3 is equal to C. What is that? Exterior angle of a cyclic chord equals to what? Opposite interior. What about this one? Third angle. Oh, AMB is what? Similar to triangle what? ACD. Once I write that, I write my ratio. AM over AC, MB over CD, AB over AD. What am I looking for? Check your letters. I'm looking for BM and AC. Can you see already I have a pair? CD and AM. Oh, but AM is the same as what? CD. Oh, so I can just replace it. CD over AC, MB over CD. Cross multiply. Can you see my working backwards? So when they give you such things, sometimes you need to break it down, identify the triangle used, and try to work your way back to the original question. Linda Kutle, I don't know if I made sense.
You did, thank you, sir.
All right, don't worry, we'll get there. It's the first question that we're doing, so don't worry. We will get there. We will get there. What am I looking for now? Yes?
So if I decided to work from where you have triangle ABM is similar to triangle ACD, and then I just did AM over AC equals to MB over CD, and then I just have CD over AC equals to MB over CD instead of having that whole.
No. You cannot prove that those triangles are similar if you don't have that list.
Okay.
Similarity, you must prove angle first before you start saying those triangles are similar. We are just lucky in this case they broke it down for us into 2. You would see some questions straight, they say prove, and they don't give you those triangles that are similar. You have to make sure that they are similar first. All right. The more we go through different questions, you start seeing the different variations. Okay? But what I want to do is I want you to learn per question and keep adding it to the skills. The length of CN, there's one here now that is 6 marks. How do we go about the length of CN? Oh, we have so many lengths, right? Oh, let's see. They gave us AC as what? Let me do this. Don't worry, guys. I know it's quite hectic. Trust me. Euclidean is not something you just play. And unfortunately, they're only given 2 weeks for this, according to the syllabus. AC is what? Ooh la la. We have some information we're given, right? AC is 36. What is AD? 48. What is BM? Where's my B? BM is what? 24. What are we looking for? CN. So if you look at this, Cn has not appeared anywhere in our workings, right? That's why we have a bit of work to do. Cn has not appeared at all in any of the things that we've done. Okay, I want to think with you again. And that's why I like to take fresh questions, because I want to think afresh. All right, my good learners, do you notice, this is the first thing coming to my mind. We have a triangle with what? Parallel lines, right? And if I have triangle with parallel lines, what can I do? I can use what? Proportionality. Let me draw it out for you again. Just keep your eyes, it gets messy, that's why I want to keep drawing. I have that, and I have that, and I have a parallel line. Do you see that? Okay, don't worry, this is the last one. I see it's already it's draining you already, I know. A, C, D. Once you get used to this thing, it's going to become very nice. Look at, I have this. When I have a triangle with parallel lines, I can try to bring in what? Proportionality. Okay. What am I looking for? Cn. Can I say Cn over CD is equal to, please check the movement, Cn over what? Over CD, what would it be? The other side.
Oh, AM over AD.
AM over what?
AD.
AD. What would be my reason? Proportionality what? Theorem.
I said this in the start, so
And what are we going to have? AC parallel to what? MN. You must always have that. What am I looking for? Cn. Do I have CD? No. But CD squared, check. CD squared equals to what? BM multiplied by what? AC. Do I have BM? BM is given. 24. What is AC? 36. The square root of it should give me my CD. $12? Oh, so I have CD. Can I go back to my equation now? I don't know Cn, right? Do I know CD? Do I know AM? But AM is the same as CD. 12 root 6. What is AD? 48. We're given. Let me know if it makes sense. Talk to me, everybody. You're going to get used to it. When I see triangle, you have to keep trying until we get it right. When I see a triangle with parallel lines, first thing that comes to my mind, proportionality. Write it down. You see, Euclidean, you write down and see if it's not working, you discard. But you can't just think, and not, because there will be too many letters in your head. You've got to write it down. Sometimes you just get it at once, like your first attempt, boom, and then you move on. But if you don't write it down, we're going to struggle. What's your answer? 18. 18 units, right?
Yeah,
18 units. Learners cry a lot on this. This is going to move you from your comfort zone. Huh? So you've got to learn the little secrets. Like, go through the points I gave you, tips. We're going to get there. We'll get there. This is the first lesson, so it's bound to be hazy. You're still trying to figure out the points. Make sure, let's read those points again. When I have this, what do I do? When I'm looking for this, what do? After a while, it's going to become something very routine. I'm not saying you're still going to be able to get some questions are hell. Trust me, it takes me time sometimes. But it gets easier and easier once you know those little principles. Why did I use proportionality here? I looked at the triangles. I see I'm looking for, can you see I drew it out? I'm looking for CN. Oh, but I see a triangle with what? Parallel lines. Once I see that, write your proportionality and then inspect. Immediately I wrote this down, I had confidence to continue. Because I quickly ran through my head. Once I wrote it down, I checked. I'm looking for CN, but I need CD. I'll tell you what I did quickly. A little secret. When I wrote this down, I kept my eyes here. Right? And I saw AM. Oh, I'm AM. I have a problem, but I know AM is what? CD. Then I ran here quickly. BM times what? AC. Do I have BM? Do I have AC? Okay, I know that already. My CD is done. And this is also what? CD. Now, what is this? AD. Do I have AD?
Yes.
Yes. Were we given?
Yes, but the 8 units.
Yeah, AD was given. So I quickly ran through but if you just discard this, like CD, you don't have, boom, you'll be lost. Are we good together, everybody? It's going to get better. It's going to get better and better. But what I wanted to focus on, please, don't play with your grade 11 ones. The greatest one is going to hit you hard. But cushion yourself quickly with the grade 11. Make sure the grade 11 you do as many as possible. Then grade 12, I will start using the tips. I promise you that by next lesson, you'll find it a lot easier. Okay, this is how it works. Oh, all right, this is how it works. Okay. Just make sure you get the tips. Use the tips in your class. When you get to school, use the tips as they are going through activities. The tips will help you. You're not looking everywhere. You're not looking everywhere. So please get back to the tips. And I'm glad we added to the tips so that it becomes easy. Learn the tips. Tip 1 usually is 10, but I'm glad I added. And the one that I forgot, I added it to it. So we're good. Are we okay, everybody?
So,
Yes?
can you go back to the tips? I didn't take down the 11th one.
Number 11.
So do we have extra class here in school? From this week?
Guys, are we good? Any question? Let me know quickly.
First, weekend.
How many? I should show the midpoint theorem. I had 2 of them, but I think just write this one. Write this one. Yes. Hand up again. Whose hand is up? Is that Kwesi? Okay, Kwesi's hand is down. All right, guys. Okay, please, for now, I just want to beg you. You guys are already in grade 12. You've done the grade 11 ones, right? Let's leave the grade 12 one to me for next lesson. Just focus more on practicing the grade 11 ones. Let's master them. Because we won't spend so much time on the grade 11. Yes, we're going to touch on it, but I want to do more grade 12 now. But grade 11, we'll touch on it, just 1 or 2 per session, but spend more time on the grade 12. But for you, spend more time working on the grade 11 Euclidean. Then, together we can hammer grade 12. Euclidean is about 35 marks. Let's get as many marks as possible. Have a lovely evening, everybody, and good night.
Yes, sir. Thank you.
All right, guys. Yep.
Sir?
Hello, Vic.
Yes, sir.
Mm-hmm.
So I just wanted to ask, will this lesson be posted?
Yes, they are all posted on the link. But remember, I lost the first part, so it's going to be a bit challenging.
Okay, no, sir, it's fine. I was there for like the first part. It's just that our power also chirped, so I was having trouble with my Wi-Fi.
Oh, okay, all right. No, you'll get it. It will be on the
Thank you,
link.
sir.
Yeah.
Okay, thank you, sir.
All right.